In lesson 1.1, based on evidence, we formed the hypothesis that the Earth is flat. In lesson 1 part 2, we acknowledged that sometimes the horizon does appear to curve. However, we pointed out that just because we can sometimes see curvature, that doesn't automatically mean the Earth is a globe. With that, our hypothesis still stands, and now it has been expanded, acknowledging that different factors can sometimes cause the flat Earth to appear to curve. Now, as many already know, a frequent factor that causes horizons to appear to curve is a camera's lens distortion. When someone shows you a picture of a curved horizon, this is something important that should be taken into consideration. Neil Tyson was smart enough to acknowledge this when he spoke of this Red Bull drop photo.
Show us where the International Space Station is, Hubble, etc.
Okay. So if the Earth were actually this size, the International Space Station would be orbiting about a half an inch above the surface. And that dude who jumped out of a perfectly good balloon, what's his name? Felix Baumgartner. He would have been about 2 millimeters above the surface of this globe. That's his edge of space jump. Now, I don't. It's fine. He wants to. I don't have a problem if he does it, but the honesty of it would greatly diminish what I think people thought he was actually doing. And not only that, they made sure to photograph him standing there with a really wide-angle lens, which curves horizontal lines. Okay. So in the photo, you see this curvature of Earth's surface, and he said, "Wow, he's in space. Look at that." No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat. And then I showed examples of wide-angle lenses curving horizontal. I tweeted that.
You did.
But I don't want to be a spoiled, curmudgeon or anything. I just wanted to put. I don't.
Lens distortion doesn't just happen with wide-angle lenses. Here, Jeranism took a picture of his granite countertop with a pretty ordinary lens. Now watch what happens when he scrunched the image just like we did in lesson 2. Boom! After scrunching his level countertop, it appeared to curve because of lens distortion.
And for the ultimate proof, watch this. I drew this image, which is just a white line, perfectly straight, drawn on a completely black background. I then open it up on my computer and take a photo of it from a camera. I then condense it, and the straight line is curved. But it's a straight line, we drew it. Oh boy.
Every good hypothesis should have disconfirming evidence, a means whereby it can be proven wrong. So with that being the case, if you want to prove the curvature on the horizon is caused by the curvature of the Earth, and prove our hypothesis wrong, there are some expectations that you need to meet. First, if you're going to show us curvature in a photo, you need a control measure to rule out the lens distortion. We can call that expectation number 1. A flat Earth opponent by the name of Mr. Sensible did an excellent job of meeting this expectation when he used a set of strings as a control measure. With this, the rule was the horizon could not be any more curved than the strings were. If the horizon was more curved than the strings were, it could not be because of lens distortion. This is because, with lens distortion, the center lines are never more curved than the outer lines. So when Mr. Sensible attached his camera to a balloon and launched it over 37,000 meters into the air and found some curvature, we couldn't say it was because of lens distortion, because he fulfilled expectation number 1. With that, he thought curvature equals globe, therefore he wins.
Now this drop-dead gorgeous image is at 35,160 odd meters. It is stunning. There is no doubt that there is curve there. That horizon line is across the middle of the field of view. So barrel distortion up or down is not going to be taking effect. That is a smoking gun. But let's have a look at it compressed. And I'll add a horizontal yellow line again for completeness. Oh look, We done got curve. I'd say it's game over for flat Earth.
But remember, in our last lesson, we mentioned how the presence of curvature doesn't automatically mean the Earth is a globe. There were still more expectations that he did not fulfill. As we mentioned in our last lesson, the atmosphere can also cause our horizon to appear to curve. This also needs to be factored out. A simple way to do this is to determine if the horizon has the same amount of curvature all the way across. We checked for this in our last lesson when we measured the curve in this image and found that the left side was more curved than the right side was. Notice here how MC Toon also had a means of ruling out lens distortion. However, he failed when it came to meeting the second expectation. To be clear, expectation number 2 was to rule out the atmosphere by showing a consistent amount of curvature. Let's see how Mr. Sensible did at fulfilling this expectation. Adjust brightness and contrast. Alright, now we're going to zoom in. We can see those pixels. We can see that rate of curvature over here. We can measure it out if we wanted to or needed to. But as we go all the way across, all of a sudden we start getting these big long stretches of straight horizon. So that's not showing us a consistent amount of curvature. It's a lot flatter over here than it was over here. So with that, Mr. Sensible failed to meet expectation number 2. On that same note, I want to point out a different way curvature is being created in this image. I'm going to go ahead and put a red arrow right where we see the horizon line. I think that's pretty good. Now I'm going to adjust the brightness and contrast, and we're going to see if that... You'll see here that our horizon line is suddenly rising now. Going up and up and up. And if I go the other way, it's going to lower. And the reason why this is happening is because this curvature that we're seeing is not being caused by the curvature of the Earth. It's being caused by the light reflecting off of the atmosphere, the sun's spotlight. And this can be seen even stronger when I adjust the brightness and contrast, and you can see the bottom part of our spotlight, the ring or circle. You can see the spotlight effect going up. There you go, on the bottom there. I guess that's... There you go. Here I'm trying to point out the bottom curve of the sun's spotlight. Now let's compare that to the horizon we see on this ball. I'm going to go ahead and adjust the brightness and contrast on that. Black and white. And notice how our horizon line doesn't appear to move around. It's staying in the exact same spot. And that is because our horizon is being created by the curvature of the ball. So here Mr. Sensible failed expectation number 3, ruling out the atmosphere by showing us a hard horizon line that doesn't move when you adjust the brightness and contrast. Although, you should also keep this in mind. Please notice how this flat stage appears to curve when you shine a circular spotlight on it. Now watch what happens when we adjust that brightness and contrast. That horizon line doesn't appear to be moving anywhere. So that's definitely something that should be taken into consideration. Oh, now it's moving somewhere, but not very much, just a little bit. We'll call this expectation number 4. If you want to prove that the curve is being created by the curvature of the Earth, you need to prove that the spotlight effect is not taking place. Expectation number 5 applies more to video footage. It states, curvature should gradually become more and more visible at a consistent rate as you rise in elevation. So when Mr. Sensible's horizon at 25,000 meters was flatter than it was at 15,000 meters, Mr. Sensible failed to meet that expectation. All in all, I can describe all of this as a successful parry. Our hypothesis has withstood Mr. Sensible's balloon test. However, we haven't proven our hypothesis true yet. We haven't yet defeated our rivaling hypothesis that the Earth is a globe. But our hypothesis that the Earth is flat is still standing and is able to continue on to the next bout. That is something. However, the main thing I want you to remember from this lesson is our list of expectations. The things that would disconfirm our hypothesis. There are also additional expectations after this, but we'll talk about those later on as we talk about the z-axis. We'll also be providing some additional evidences and be proving some points as well, so I look forward to that. Until our next bout, thank you for watching.